So hey everybody, today we've got Adam Olshansky here to walk us through all the fun and excitement there is with doing Apex testing. This one's, I'm pretty excited about this one because I really do enjoy testing. There's a lot of stuff you can find with Apex tests that you wouldn't necessarily think of. So with that, I'll turn the floor over to Adam and let him take us through here.
Yeah, thanks, Jason. I appreciate it. All right, so I'm gonna go ahead and share my screen. All right. Hopefully you're seeing the PowerPoint. Cool. All right. So yeah, thank you again for having me for my presentation on Apex testing, a deep dive. And so for those who don't know me, my name is Adam Olshansky. I'm a Salesforce MVP and Salesforce architect for Google Play. I have over 700 Trailhead badges and 15 certifications, but I'm really passionate about helping people code on the Salesforce platform. Feel free to follow me on Twitter, Adam17AMO. Check out my blog, adam.architect.com. And I have some Pluralsight courses I launched earlier this year. If you're interested in getting a deep dive into Salesforce data sharing, there's a link for a data sharing course. And then if you're interested in going after the platform Dev 1 cert, I have a couple courses out on that. The first one on fundamentals, a link for that one as well. I don't have the link here, but I'll have it at the end of the slide. All the code I'm going to be sharing during the presentation, I have a GitHub repository. You can get all that from as well. All right, so thank you again, Tampa, for having me. I've never had the pleasure of actually visiting, but I am a big sports fan, and I've seen a lot of championships and a couple championship heartbreaks out of Tampa recently the past couple years. Being from Arizona and having no championships, I'm very jealous, but congrats all the same. And thank you again for having me. All right, so in terms of testing, what we're going to talk about today, I'm going to start off just with some kind of overall testing basics, and then we're going to really start our deep dive talking about the system level test class and how to test asynchronous code. We're going to go into testing callouts from Salesforce as well to external systems. And we're also going to do a deep dive into debugging failed tests using the Apex Replay Debugger. So a couple of demos mixed in here. And then we're going to wrap things up, share the code, and talk about where else you can test on Salesforce. All right, so let's start off with some testing basics. And the first question we ask is, why are we testing to begin with? And well, the first reason is really just to ensure that our code is working, right? That's kind of very basic. Why do we test anything? We want to make sure whatever we're building is actually working. And the next thing, why we test, well, Salesforce actually requires it. So for us to send any sort of Apex code to production, we have to have 75% code coverage on all of our Apex code. Another reason we test is to catch bugs early on. So it's always easier if we catch bugs ourselves from our tests than if users are catching them and we have to do an emergency deployment later. And the other big reason is to prevent regressions. And when I mean regressions, this is things like, right, my code is working today, I introduce a new feature tomorrow, and my original functionality breaks. Well, how do we do that? One option is we manually retest everything that our application used to do. Or a better option is to rerun all of our tests that we know ensure that our previous functionality was working. So if we launch new features and all of our tests are still passing, we can be pretty confident that our previous functionality is going to continue working as well. And the other reason why we test is to avoid ending up like this guy. We roll out features and we like to think users will know how to use them. And users are always finding interesting ways to use the functionality we built for them. And so writing tests and trying to account for some of those maybe interesting use cases will make sure that we are catching the problems ahead of time rather than users finding them along the way. All right, when we talk about how do we structure a test, pretty much every test should have 3 primary components. Just a reminder, when you run tests, it should not be working with production data. And so it's going to be working with a separate data set that you need to create. So whenever you are trying to run a test, you need to create that basic test data to simulate what a user might be experiencing in the real world production environment. Once the test data is in place, you can actually run your code and run your functionality. And once your functionality has run, you actually go ahead and assert the results, basically make sure the code worked like you thought it was going to work. Right? If you're writing tests without assert statements, you're not really testing anything. You're running the code, you're getting the coverage, but the test is kind of pointless because you didn't double check that what you built is actually working properly. Right. And in terms of creating the test data, that initial step, there are a couple different ways to create it. I'm not going to go into them too deeply today. Just at a high level, if you haven't heard of these things before, I recommend looking into some of them. One option is just manually create it in each test. Sometimes you're just running a very basic test that needs a single record, for example. You can create that either with a DML statement or even just in memory and run your test on it. Another option, if you want to standardize the data you're creating for multiple tests, you can just put it all into a CSV as a static resource and load the data from that. And that way you'll know you're going to be exact same data for each and every test. Let's say you want to test some functionality on accounts. You can have the same 10 accounts running for each and every test by loading it as a CSV. Another way to do something similar is by the test setup, putting a test setup annotation into your tests. So this is a method at the beginning of your test class that will basically run before every test. So instead of having to recreate the same data for each and every test, just throw it into your test setup method. It'll run on its own before each test, and you can reduce the need to duplicate your code there. And the other way that I think is very common and useful for creating data is what's called a test factory. This is basically a separate class for just creating data for test purposes. And this will help you ensure that, again, you're creating the same data for all your tests across your org, and also makes it a lot easier when your schema changes. So for example, if I'm creating accounts for all 10 different test classes, and somebody adds a new required field on account, that means as a developer, I have to go add that required field now to each of my 10 test classes, right? And so that's a very kind of brittle way to have your code working and very easy for it to break if somebody's making changes to the schema. And so with a test factory that I'm using in all of my test classes to generate accounts, I can have a single place to update my account records I'm using for my tests, add the required field there, and it's going to fix everything a lot quicker than trying to find it in each and every test class. All right, and then some bad habits for tests you want to avoid. Again, I mentioned not putting any asserts in your tests. You might think you're like this guy here, but it's going to end up costing you in the long run if you're not actually testing the code you're writing tests for. Asserts that don't cover the part that was tested. I've seen that before. People just think, oh, I'll throw assert statements in there and that looks good. But they're not actually testing what they're supposed to be testing, right? They'll create an account and then they'll confirm that an account was created, but they won't actually confirm that the fields were properly updated. So again, not necessarily an effective test. And the other very bad habit I've seen is just putting fake code in your classes to meet coverage requirements, right? You might have seen long blocks of text with just a bunch of nonsense. It doesn't do anything, but it's very easy to test because it doesn't do anything, and you can meet your coverage requirements faster. Again, you're really only cheating yourself, and it's a bad practice to get into. So please, this sweet little cat is begging you, do not do any of these things. All right. So let's talk about the test Apex system class and how to test asynchronous code. And so I'm talking about the test system class. I'm talking about basically anything that starts with test dot. So these are going to be things like test.start test, test.stop test, that you can use to basically reset your limits when you're running tests. So one of the annoying things when you're running tests, right, you want to create all your data at the beginning. But the problem with creating all your data at the beginning is that uses up a lot of your governor limits. If my account triggers are running and it uses 20 SOQL queries, now my test only has room for 80 SOQL queries, whereas a user has the account already in place and it's going to have that full 100. So to make your tests more simulate a real-world experience, once your data is done being created, you can throw test.start test in there and it's going to reset all of your limits. So when you run your actual code in the test context, you're not going to have to worry about the limits that got wasted actually creating that data. And then to end that block, test.stop test will put you back in the original limits context. Another way to avoid limits in tests is by bulkifying record creation. So instead of inserting records one at a time, insert them in bulk in a list or some sort of collection. Another way is creating records without DML. So there are some cases where you have to have a record in the Salesforce database to use it in your code. There are other cases where you're just doing some logical checks on a record. it doesn't need to have an ID, or it doesn't need to have a real ID necessarily. You can just create it in memory and not actually spend any DML on it. And it'll also save you some time on performance because you don't have to wait for the system to actually process the DML. So another kind of workaround if you don't need the record in the database, how to create it without DML. Another kind of common pattern you'll see in test factories is a Boolean in each method, called insert DML that you can toggle on as true or false. Sometimes you want to create the records and insert them in the database. Sometimes you just want to create them in memory. And so it's a very easy way to toggle with a Boolean in your test factory. And the other way to do it is to split up tests by use case. So, and I've definitely fallen victim to this before, where I create a bunch of test data. It's a little bit of a pain. And then I go through my tests and I think, okay, I'll just test 3 different things at once. They all use 40 SOQL queries and I'm running through my limits. Okay, well, that's kind of annoying. And rather than just trying to test everything at once, just treat it like you would a user. Break it out into separate tests. That way there'll be separate transactions and you'll be able to avoid some limits that way as well. In another way, test.isRunningTest, probably not that common a pattern, but you potentially can do some checks within your code to see if you're about to hit limits, or if you're running in a test context, you may need to your code to behave a little bit different while it's in a test context versus not in a test context. And you can use the test.isRunningTest method in your code to check for that as well. All right, and one thing to note on these as well, we had a developer on one of my teams in the past who, coincidentally, it was his last day, but he created a class in the org called test. And it broke all of our tests because all of these test.startTest and test.stopTest were calling the test class that we created instead of the Apex system level test. And obviously, the class he created didn't have all these methods in it, and so all of our tests started failing. So I don't know why Salesforce even lets you create a class called test, but I definitely recommend against doing that as well. Like I said, a little bit of a coincidence. It was this guy's last day. So I don't think he was trying to sabotage us, but you never know, I guess. All right, so how does this relate to asynchronous testing, right? If I want to test an external callout of some kind. So when I'm talking about external callouts are later, asynchronous testing. So these are tests that don't actually run immediately. They run when system resources are available. So these are going to be things like future methods, batchables, queuables, and schedulables. When you are testing any of these, normally it will run at a certain time, right? When system resources are available at a certain time frame. In the case of schedulable, batchable might take a little while. And when we're running a test, right, we don't want to have to wait until midnight for our schedulable job to run. And so we need a way to make it run automatically. And so putting test.stopTest into your tests will force the asynchronous code to run synchronously. So it will run immediately upon saying test.stopTest. And you'll be able to do your asserts after that as well. One thing to know, which definitely tripped me up on schedulable though, the schedulable job will run, but any thing that it is scheduling will not. So if I'm scheduling a batch job to run, for example, the schedulable class will kick off and I can do queries to verify that it does run, but the batchable job that it's scheduled will not actually run. So I still need to manually run the batch job on its own, even though I called test.stopTest for the schedulable. So weird quirk, I don't know why it works that way. It's something to keep in mind, but you can use test.stopTest to force your asynchronous code to run as well. And then verify it properly ran.
Yeah, there was one other one. There was one other scenario we ran into recently using platform events. If you have code that runs within a platform event, test.stopTest will sometimes make it run. But there are certain scenarios if you have a platform event that then triggers off another platform event. So you have a chain, it won't necessarily, it'll do the first one, but it won't ensure that it'll do the last one. There's something with the event called ensure execution or something that you can use. I can't remember the exact syntax, but I remember we ran into that and I was like, well, it should stop when you say stop. It should execute when you say stop test. And it did the first one, but not the subsequent one, which is kind of the same thing like you mentioned with the schedulable calling a batchable or something.
Interesting. Okay, I'll have to look into that and add that to the slide for future reference. Yeah, thanks for the heads up. Yeah, so definitely effective, but yeah, some weird quirks that are built in with some of that for sure. All right, other times you might see this test system class pop up. I mentioned test.isRunningTest before. Test.setCreatedDate is a relatively new method, but when you're creating records in the context of a test, you actually have the option to change the system created date field on a record. So sometimes you'll have functionality that you say, okay, treat records created before this date a certain way, treat records created after this date a certain way, and you can change the created date on your records that you're using for your test to basically simulate that previous experience. Another one you might see if you're testing Visualforce pages, test.setCurrentPage, just to put in context a certain Visualforce page you want to test. So that's another common use case of this class as well, and there are a couple others. So recommend looking around the documentation on that. All right, so I'm going to jump into a demo in a second here, and I'm going to demo a class called, we're going to test a class called CaseReassignmentBatch. And in my org, I have a process where any new cases are assigned to a queue called the temp queue. And when the case reassignment batch runs, it's going to take all the cases that are owned by the queue, and it's going to assign them to some specified user. And it is a batch job, and I'm going to show how we can test it to make it run immediately. All right. And I'm going to demo a couple other things in the test system level class here too. So let me move this out of the way. So hopefully you can see this. Let me know if I need to zoom in at all. But this is the case reassignment batch. So we see here the constructor is line 5 to 7. It just takes in a current ID to basically be the person it's assigning everything to. Our start method is just going to query every case owned by the temp queue. And our execute method is just going to take all those cases, change the owner to be the current user, and update all the cases, and then it's going to keep a counter as well, and then print out how many cases it assigned. And so if I go look at the test class test here, I'm going to run this test while we talk through it. So I see a test called test batch reassignment. I'm going to use my test factory to create 10 cases. I'm going to assign them all to the temp queue and update the cases. We're going to confirm that all cases should be owned by the queue in line 36. In line 39, we see I call test.startTest. I run my batch in line 41. I call test.stopTest to trigger the batch to fire. And then in line 45, we're going to get another query of how many cases are owned by the temp queue. Assuming our test passes, line 46 should confirm that no cases are now owned by the temp queue. And line 47, we're going to get a count of cases that are owned by the current user that we passed into our reassignment batch. And line 48 should assert that all cases are in fact now owned by the current user. And hopefully our test finishes here. Okay, so it successfully ran. So we see that it ran upon test.stopTest, and we see that now all of our cases are owned by the current user. Okay, great. So we saw asynchronous code. Let's take a look at some of the other test functionality. So I have this other test here. I'm going to start it running early, I guess, now, where I'm going to create 100 new accounts. And I'm going to do something absolutely terrible. I'm going to put a SOQL statement in a for loop. And I'm going to max out my governor limit here in line 8. And so my for loop is going to run 100 times, hitting my SOQL limit of 100. In line 11, I'm going to confirm that I have in fact run 100 SOQL queries. Line 12, I'm confirming that the 100 SOQL queries I have run is the same as the limit for the maximum number that I can run in a single transaction. I'm then going to call test.startTest. I'm going to then assert that I've actually run 0 queries because my limits were reset in line 15. I'm going to then run 10 more SOQL queries, another SOQL statement in a for loop. Do not do that. Line 20, I'm going to confirm I've actually only run 10 queries now. And then I'm going to stop test and go back to my original context. And so I'm going to run 110 queries in the same test. And we see that despite that, it is still actually passing. Okay. All right, and so again, test.start test, test.stop test will allow us to reset the limits. And the last thing in the test class I wanted to share was here we see the test.setCreatedDate. So I'm going to create a new account corresponding to the first Harry Potter movie. And we'll start that. I'm going to create a new date time in line 55 and specify that it was November 14th, 2001. I'm going to use test.setCreatedDate to change the created date on that account. And when I go requery the first Harry Potter movie in line 58, I'm going to confirm that the created date field, that is a system level field that's normally read-only, actually now matches up with the date and time that I specified the first movie release. And we see that that test passed as well. All right, so test system level class in action. All right, let's jump back into our slides here now. And okay, now we're going to talk about testing external callouts. And we can test external callouts using something called mock tests. So you may or may not be aware from Apex Test, you cannot actually make external callouts to non-Salesforce systems. And so because of that, we still want a way to make sure that our tests that are calling external systems are going to pass. And so what we can do are create what are called mock responses or fake responses to basically make sure we can handle whatever our APIs are going to be sending back to us. And once again, we're going to use the test system level class for that using a method called test.setMock. Okay. And to do that, we're going to generate mock data. And basically, we're going to generate a fake API response. And what I like to do is to just model it after actual API responses. So I'll usually make a call out to my API in a sandbox, capture whatever that response is, and then use that in my mock data for my test to make sure it's all formatted properly, usually in the form of a JSON. Another thing we want to make sure we're doing is to test for multiple occurrences. So we want to make sure that everything's working for our positive 200 response when everything works successfully. But what about when things don't work as well as we expect, right? What if we get some sort of permissions error? Or what if we get some sort of like server error on the other side? We want to make sure we're able to handle non-successful responses accordingly as well. And so in our mocks, we want to make sure we have good and bad responses to be able to test with to handle in our code. Another option, so a couple options we can do this. We can, like we're going to see in our demo, use the constructor to determine what sort of response we want to generate. We can also create a map to hold multiple responses. We can have a map to hold multiple endpoints if we're testing different callouts. We can use that as well. So a couple different ways to go about testing our external system callouts. All right, so the scenario I'm going to walk through here, we have a custom object called purchase order. And we have an external system that's going to sync data back to Salesforce for purchase order information based on an external ID. So there's an ID in this external system, and it's going to correspond to an external ID in Salesforce, mapping to a purchase order record. And we also want to make sure we're handling different responses from the API. Again, good and bad responses should be accounted for. So here's a snippet of what our code looks like. The important parts here are in red. We see at the top, we have some sort of HTTP call we're generating, and we have an endpoint we're calling, and part of that endpoint is going to be the external ID that we are passing into our method. So we see we're passing in an external ID and a Salesforce ID. So the endpoint's going to use our external ID. And then later on, we have a try catch block, and we're going to try to basically make a call out here. If we get a positive 200 response, great, we can parse the JSON, and we can call another method to actually update the purchase order in Salesforce with our external data. Otherwise, for now, we're just going to print out a system.debug message. And if I take a look at our update purchase order method, basically, we're just going to be taking in our wrapper object we got from our JSON. We're going to be querying our record in Salesforce, and then we're just doing a mapping, right? Amount to amount, amount remaining to amount still owed, description to description, name to name, and then we're going to update our record. So this method's pretty simple. Okay, and all right, so let's go take a look at how we want to go about testing that, knowing we can't actually make a call out to this external system. So to do that, I'm going to pull up, okay. Oh, this I meant to show in the last method here. We have an option to use test.isRunningTest to either make an external callout or make a test callout. But this is basically a better version of testing external callouts. So we have our test class here. And I'm going to start running it because it takes a little while. But we see all we're doing we're starting with testing a successful purchase order sync in line 4. So here we're just generating a new purchase order, giving it an ID, ABC123, and inserting it. And then we're going to go about mocking the response. So first we call test.setMock, and we are calling a class called new purchase order mock. And if I go take a look at purchase order mock, we see it has an @IsTest annotation. If you want to take a look at the code afterward, there's a link to going about a different way to create mock data with a map approach for different endpoints. But for now, we're just assuming the same endpoint for everything. I have a constructor that takes it as status code. And you'll notice in line 2, the mock class has to implement an interface called HTTP callout mock, which has a single method called respond. And respond is going to take a request and basically return an HTTP response. And so here we are going to, in line 13, set the status code based on whatever status code we passed into the constructor. And based on what the status code is, we're going to set the status. If it's 200, it's going to be okay. If it's 403, it's going to be an authentication failure. And if it's 500, it's going to be a server error. And then I have other methods to set the body to either an okay response, a failed response, or a server error response. And then we can return that response. And we'll see that these responses are just JSON files modeled after a real sort of call out. Information about making a Dreamforce purchase for Astro plushies for the positive one. And then for the failed ones, we just see authentication failure and internal server error. Okay, so with that in mind, let's go back to our test now. And we're going to set in this test our mock to be the purchase order mock with a status code of 200. And we're going to call our code to sync the purchase order, which remember is supposed to call the endpoint. And instead of calling the external endpoint, it's going to call our mock endpoint, get our mock response back, and we're going to pass in this JSON here, like it was coming from an external system, map it to our purchase order, update all the values, and we saw here our test passed because we successfully updated all the values from our mock response despite only populating the name and the external ID and our original data. So we see that our mock response was successful. And we can do the same thing here for our failure responses. The same sort of structure here, and the only difference is line 31, we see we're passing error code 403. And the difference is, while the name we updated, all the other fields did not actually get updated because we got a failed response back from our mock. And the same thing will be the case for our 500 status code. Nothing's actually going to get updated because our 500 response does not have any of this data. So that's one way to update based on mocks. One other way is to use a static resource. So I can have a static resource in here called purchase order response.json. And again, it's just a JSON file with a static resource that I've uploaded, very similar to the mock response. I have all the fields populated in here, the OK status, the status code. And if I go run this test here, we're doing something very similar. The only difference is we're using this static resource callout mock class. And we're going to set the name of our static resource we're going to use. We're going to set the status code. We're going to set the mock to be this static resource callout mock we've generated. And then we're going to see once again that all of our data successfully got updated from our static resource instead of from our mock class instead. All right, let's go to our next topic then. All right, so we saw different ways to mock. We talked about using a constructor to get different response codes. We can pass in different responses as a result. We talked about using a static resource, and I also mentioned you can also use a map if you have different endpoints you want to test in the context of the same test. All right, so now let's get on to debugging tests. And we're going to be using the Apex Replay Debugger to basically solve a failed test in our scenario here. So why do we go about debugging tests? What do we mean when we say debugging failed tests? Basically, there are a couple ways to go about doing this. One is a sanity data check after test setup. So what I like to do after my test setup is run, before any of my code is actually run that I want to test, I put in some assert statements. So if I created a case in my test setup, I just verify a case has been created. Or I even just get a baseline for how many cases were created. In case something changes along the way, later on, it can compare the before count with the after count to make sure it's either the same number or maybe one case has been added. So instead of saying, okay, well, right now there's one case, later there's two cases, maybe some process is going to change that later on. So right now I say there's a certain number of cases, and then I just say, okay, after my code is run, there's before count plus one cases now. The other thing to do is include try catches. So you can, catch errors, see where things fail. Maybe you're expecting something to fail, make sure you're able to handle it accordingly. And use system debug all over the place when you're trying to debug failed tests. Another thing I do if I'm running into limit errors, I use the limits class to check how many limits have I run at certain intervals and help me adjust where to put that test.start test and test.stop test as well. All right, and another way, so those are all kind of common ways to debug tests. Another way is a tool that's a couple years old now called the Apex Replay Debugger. And this is a tool that basically allows you to run through your tests, capture the logs, and then run through the logs step by step to figure out exactly where your test is going wrong and what's happening to your variables. And so with your replay debugger, you're able to set breakpoints and checkpoints in your org, and those are just basically places where your log is going to stop running when you put it through the replay debugger, when you're replaying those logs. You're able to set unlimited breakpoints to stop at and up to 5 checkpoints, and checkpoints just give you some additional data with your variables and things like that. So it not only will stop, but it'll give you some additional data to troubleshoot as well. And you're able to find errors and try to see where exactly your test is going wrong by replaying all these logs. And so we're going to walk through a failed test here and see how we can potentially fix it. And so I'm going to start off by navigating to my failed test. So I have a test called test factory tests. And if I run this test factory 2, so the scenario here is I have an account trigger that is, let me see that it failed. And if I move this out of the way, okay. So we see that it failed, and basically it is using that functionality you might have seen on websites where you check a box to match your billing address to your shipping address. All my trigger is doing is it's taking the billing address that is populated, and it's checking to see, okay, if match billing address is true, basically set all the shipping address values to the billing address values. And we see right now it is failing with a note that the state should match. So it's failing line 37 here. I'm expecting the billing state to match the shipping state, and that is not the case right now. So let's go use the Apex Replay Debugger to figure out where we went wrong here. So if we want to use the Apex Replay Debugger, it does come built into VS Code with the Salesforce extension pack. And to get it working, you may or may not have to do this. I think I had to do this at some point, but you may need to create a directory just called .vscode. And in .vscode, just create a file called launch.json. And within launch.json, you'll see this little box here called add configuration. And when you click on add configuration, it'll let you basically choose a new configuration for the Apex Replay Debugger. So I've gone ahead and already done that here. And so I have some configuration to run the Apex Replay Debugger. After I've configured this to run, I can go and start putting my checkpoints in place. So I'm going to navigate to my account trigger. I know if I look at line 37, something screwy is going on with the shipping state. So I'm going to go put in some checkpoints to basically have my code stop when the shipping state is getting changed. So I see the shipping state is getting changed in line 11. So I'm going to put a stop right before. So I'm going to go run a VS Code command, toggle checkpoint. And I see a checkpoint will show up here in line 8. I'm going to toggle another checkpoint where the shipping state is actually getting updated in line 11. And then after that runs, I'm going to do an after check. So I have a before check, a current line check, and an after check to see exactly what is going on in this change here. Once I have all my checkpoints in place, I can run another command, update checkpoints in org. So VS Code knows to register all my updated checkpoints now. So I can go ahead and do that. And a couple steps will run here. So we see step 6, confirmed, great. So once all the checkpoints have been updated, I can run another VS Code command to turn on the Apex debug log for Replay Debugger. So now it'll start capturing logs that I'm going to want to replay. So I'm going to turn that on. And once that's on, I'm going to run through this failed test again here. So, okay, great. It's on now. So let's run through the failed test again, and we can capture the logs for it. Another method you can do is go into debug logs in your org and just download the log and then run it from there as well. Basically, it just needs a log file to actually replay. And so those log files are going to end up showing up in, I believe it's .sfdx tools debug, or debug, yes, /logs. And so we should see another file show up here in a minute here once this test finishes running. But these are basically all the logs the VS Code has captured that we can walk through. So it looks like it's finishing, hopefully finishing that up right now. And once it finishes, we'll be able to open it up and run it through the Apex Replay Debugger. And well, the first time it ran very quickly. Let's see. Okay, so what we're going to see in a second when we're running through the debugger, we'll be able to go back to those checkpoints, and we'll be able to stop it basically at each of these places that I've placed a checkpoint. And we'll be able on the side here to see all of our variables so we can compare and figure out what exactly is going on. It's all going to happen in this run and debug section in VS Code you may or may not have used before. And it's taking a longer time than usual. I'm going to cancel this and just run it again. Hopefully that was not a mistake. Now we can try running through a previous log here as well. Okay, so now we see it failed, great. And same failure as before. So now I can either go and figure out which log is the right one, or I can run a command that says get Apex debug logs, which is even better. And it'll ask me, which log do you want to get? I'm going to get the one that I just created right now. It's 3:42 p.m. here on the West Coast. So it's going to open up this log. And once the log is opened up, I can right click on it and click this one that says SFDX launch Apex Replay Debugger with current file and start replaying this entire log here. So it's going to load the log up into the system now and get ready to replay it. And we see now it's ready to start at this first line in the log here. So I'm going to basically replay my test, stopping at the checkpoints I put in place. So I'm going to continue. And it started off, you remember, it was just creating my account and then running through here, updating my account, and we were expecting it to populate my account correctly, and it did not. And the first place it stopped here is at my first checkpoint in line 8. I could see I have a couple global variables, right? Trigger.new, trigger.old. But we're interested in our account A that's running through our loop here. And so I see my A local variable showing up on the left side here. And so if I expand A, I can scroll around here, and I can see it populated a billing city. I think this is Harry Potter's address, 4 Privet Drive, Little Whinging in Surrey in the UK. But I see here I have my billing city, I have my billing street, I have my billing state, and I've not yet populated my shipping state. So, okay, so as of line 8, everything seems to be okay. I'm going to go now jump through to my next checkpoint, line 11. So now I've populated my shipping city. And so somewhere in here, I should see shipping city populated. And I have not yet populated my shipping state. And we know that's where the problem is happening. So let's go update our shipping state, jump to our next checkpoint, and see what's happening with our shipping state. And I'm going to jump down here to line 14. We see our shipping state is populated. And we notice that it is matching our shipping city, which is also the same as our billing city. And so that can be a good indication that something is going wrong with that specific line. And if we go and look at our code, sure enough, the shipping state is being set to the billing city instead of the billing state. Okay, so now we've been able to find the problem. Let's go ahead and stop our replay log now. Let's make an update to billing state, save that, push it to our org. And once we've pushed that update to our org, now the state should be getting set correctly. We can go run through our test again. And hopefully with the help of the Apex Replay Debugger, we were able to find exactly where our variables were getting the wrong values, being changed to the wrong values. It wasn't happening somewhere later in the code. It was actually when it was first being changed directly. And we see now our test is successfully passing thanks to correcting that error. All right, so this is another way to debug code, walk through it step by step and see where exactly your variables are getting changed incorrectly. All right, so quick wrap up here. We talked about kind of why we test. We talked about some uses of our test system level class and how to test asynchronous code. We talked about testing external callouts using mocking framework. And we talked about using the Apex Replay Debugger to debug failed tests as well. In terms of other thing you can test on Salesforce, Lightning components testing, while not required, there are some commands in the SFDX CLI to be able to run and create tests for Lightning Web Components. And I think there's some beta functionality even to be able to generate tests for flows as well. So in the flow builder, I've not used it yet, but I know there's a button called, I think it's generate tests. So potentially something that could be required later or just best practice to make sure your flows are being tested as well. With that, again, thank you so much for having me. If you are interested in the code I walked through, it's all available in a GitHub repository, Adam17AMO/Apex testing. And with that, happy to take any questions if anyone has them. All right, Jason, I see you sent me the test get event bus.
Yeah, so you can deliver the individual messages that have been pushed to the platform event bus one at a time.
Okay, interesting.
Yeah, so especially when you have multiples that get queued up, this is a way to kind of walk through them. So
gotcha.
Yeah, didn't know we needed it until we ran into it. So just the way it usually happens. So
makes sense.
All right. Well, Adam, thank you so much for hosting this event and stepping us through the writing unit tests. And I've never actually used the replay debugger as long as I've worked with Salesforce, and I've heard about it and seen demos of it, but never actually seen how to use it or how to get it set up, I should say, in VS Code. So I'm definitely going to take that and review that part of the video once it's done here. So very cool. All right. Well, thank you for joining us, and thanks everybody else for attending. I'll be posting this video once it gets done rendering later tonight or first thing tomorrow. And with that, we'll let everybody go. We do have a event next month as well, so keep a lookout for that one. And everyone else have a great rest of your day. Thanks.
Thanks, Jason. Thanks, everyone.
Appreciate it.